so we just had this test. We're going to do law of sine and cosine tomorrow. Then we're going to have,
only 5 problems?
I mean today, sorry. Tomorrow meaning like next.
Our homework's due at 3 tomorrow, right?
Yes. Then we're going to go over the stuff on Monday. We're going to make a note card. We're going to have a quiz on Tuesday. Maybe answer any questions. It's not going to take the whole period. It's not a test, so we can do more. And then we're going to make 1-pagers next week that will complete this course so that we have all of our functions like in a really good way. Because last year our logarithm one was probably kind of sketchy, and we didn't have one for trig at all. This might be like a front and back kind of thing because we've got a lot in trig that we did. It may not be like 1 page. So you might want to find your exponentials and logarithms and then just make it better because last year really we did it really quick and in COVID distance learning stuff. So this will set our seniors up for their exam, which is the following week, and we'll just have y'all so that you have a complete set of summary pages. Calculus is actually pulling those out to look at them before their exam because they had to switch some logarithms to exponentials, and we haven't done that in so long that it was good to go back and review it. So these are really handy, especially when they're written in your own handwriting, so there's no denying you did it sometime during the year. You know, you forgot it, but hey, I did do it before I wrote this down, so that's really helpful for there. So we're going to look at 8.1 today, which is the law of sine and cosine. Here we go. I should have tests for you on Monday. So we're looking at 8.1, like that pen. 8.1, the law of sines and cosines. So we feel like we've done a lot with sine and cosine already, but what we did before, so before times, was a right triangle where we had an angle and we looked at opposite over adjacent, hypotenuse, all of that. Well, what other kind of triangles can we have? They're not all right triangles.
Equilateral.
Acute and obtuse and equilateral, which is also acute, right? So we're going to look at what's called oblique triangles. Did y'all learn that word?
Those are really ugly ones, right?
Okay, but what that means is that they're not right triangles.
Yes.
So I agree with you because they're not right triangles, but
I thought oblique was the one that was like where it's got like the angle that's greater than 90.
So a lot of times they're obtuse.
Yeah.
So and my geometry terminology is sketchy, but in my notes looking through this section, they defined oblique as no right angle, so I'm going to go with that. So we've got 2 different laws here we're going to look at, and I'm going to separate them into 2 columns. The first is going to be law of sine, and I'm going to put a triangle in the middle. It's not really obtuse because that's just how it works in my space. And I'm going to name my angles A, B, and C. So they're big letters. And then in the convention of keeping up with things, I would call this side across from A like little a, right? And little c and little b, so we can tell what's happening. So I'm writing mine this way. You might want to write yours this way too, just so we're on the same page. And I know that Mr. Seiler might have made y'all laugh about some of the rules that you have and rules that you didn't have, because he didn't cover law of sine or cosine, but we've got a new one today that you didn't have before. So we have these 3, 4, 5 ways of looking at given information such that we can find the other information. So like on your test yesterday, you had a problem where they gave you sine of an angle in a right triangle, and you could find the third side, right? Because it was Pythagorean theorem. Well, this not being a right triangle, I can't use Pythagorean theorem, so we're going to use the law of sine and cosine to find the third side, or to find the, well, we could do the third angle. How do you do the third angle? Yeah, so triangles still have a total degree of 180, and we'll probably go back to degrees a little bit because that's easier to think about than radians. So all angles add up to 180. That happens in all triangles. So we have these three things. We've got angle, angle, side, or angle, side, angle. So if you're given two angles and a side, you remember those sort of abbreviations. So if we have that information, we would use the law of sines. And we have this other one that Mr. Seiler didn't let you use, which was this one, which we're going to call side, side, angle. Okay, that's what we're going to call it. Right? Right, yeah. So two sides and a non-included angle. Side, side, angle. And then over here we have side, angle, side, and side, side, side. So we have, this one's an angle between the sides, just like it looks, and this is three sides. So if we know all of that, any of those pieces, we can figure out the other angles, the other sides, based on ratios of the triangle, based on the law of sine and cosine. So the law of sines is super duper easy. Okay, so law of sines is my favorite because it's really easy to remember. It says that if you look at the sine of an angle in proportion to the side that goes with it, that it's going to be equal to the sine of any other angle. So the ratio between angle and side compared to the ratio of another angle and side will be the same. So that's fantastic because y'all agree that's an easy thing to memorize. There's no trick to it. The ratio of the angle to the side is equal to the ratio of another angle to its side. And we can actually flip this over because there's no way that any of these can be zero. Like the one thing that would break this would be if A, B, or C is zero. But if A, B, or C is zero, do you have a triangle? No. So therefore, you can also say, and this may not seem like it's that important and you would need to say it, but it's actually helpful when you solve stuff that you put it in the top. Like if you didn't know the side A, you'd want to write your ratio flipped over the other way. So just for fun, I'm going to flip it over. They go and make a big deal out of that. But I think if you just recognize that if you had a side that was zero, you actually don't have a triangle, that we're good. So you can do it either way. That's nice. We're going to do some problems in a second as example to see that. I'm going to write out the law of cosine though because it's going to complete my little chart here between them. So the law of cosine is not as easy to memorize, but it has a pattern to it, which makes it easy to figure out. So the note card is probably unnecessary because they're not that difficult to memorize. They're not like the identities that we did, but the law of cosine says if you know a squared, like this is a derivation of the Pythagorean theorem. So yeah, we're gonna have some squareds in here. It looks like part of the Pythagorean theorem, but because we don't have a right angle, we have to take care of it with this extra piece. Because A is not the hypotenuse, right? So A is some relationship between its other sides, and they have a whole explanation of this in the book that goes through the proof of it. Very geometrical. We're going to push that I believe button and say, good job, book. Let's just go and use it, all right? So can you see what's happening? Tell me some stuff about what I have here for A. Not sure. Let me write B down. And then see if you see a pattern. Or see if you could figure out C. Okay, so 2BA or AB cosine of C. So the only thing that's over here that C is the cosine of the angle. So the relationship between it being squared and its angle is important. And then everything else is in the other two letters. Okay, bless you. So we've got a squared, b squared plus c squared, and then this takes care of, oopsies, it's not a right triangle. So the relationship is whatever side you're working with the law of cosines, whatever side you're looking for, you're going to have that angle, or you're going to be able to figure that angle out with inverse cosine. So this one is kind of awkward, and we just want to learn how to use it so that if you were doing a whole theory on law of sine or law of cosine, then you could easily memorize these if we were having a whole nother big story about memorizing and learning. But we are trying to cover some topics so we don't miss them for this year. So let's look at this first example. You've got your stuff written down. So my first example, I'm going to pause the video and write it out so I have it in words. So they're up in a balloon and they can see these 2 mile markers, which we have now decided must be 1 mile apart from each other. This is the road, and we can see 2 mile markers. They've got really good vision because they can see them. Maybe they have binoculars. And they're seeing this like this. My mile marker signs are really big. This actually makes a triangle. Here it is. There. Okay. So the hot air balloon spies 2 signs and measures the angle to each. So apparently not only are they master hot air balloon drivers, they can stay in the exact same position and measure the angle. So good job, people. And in my direction, it says hot air balloon spies 2 signs. They're mile marker signs and measures the angle to each. Okay, so they measure their angle like they're looking at it and they measure it down. So when I draw it, I'm going to draw it this way. So this, and not only do they measure it with this precision, 50.19 degrees. That is fantastic. This one is 15.66 degrees. Okay. So just FYI, and I made this note to myself to make sure I told y'all, the distance between the signs is 5,280 feet. Okay, so we are trying to find out the distance of the balloon to mile marker A. So we're looking for this distance. What should we call that distance in a letter? B. Why should we call it B? Everyone should be on the same page. I named this one mile marker B, so we should call this B and this little b. How about that? Okay. Some sort of convention. We need to agree upon it, so we've agreed that that's going to be B. And so, do I know more stuff? What do I know? The other side's A. Good. What else? Okay, the bottom is little c. What else? Okay. Okay, we've named everything. What else? I need some math. We would know C, right? Okay, good. What else do we know? I'm going to do that in a second. We know, so these are outside my triangle. I need some angles inside my triangle. Isn't there like a theorem where like, isn't B, little b equals to 50.19? Yes. Right? So these are parallel lines. We're going to assume the road is flat. We're looking at, I've drawn it as parallel lines. This isn't some mountain they're on. That would be awkward. So this is 50.9. This is 50.19. That makes this one 15.66. So now I have angles inside. I could actually find the third angle by saying 180 minus these two in the triangle, the same way that Madeline said 180 is a straight line minus those two angles. Everybody see all those things from geometry that we remember? Okay, cool. So we're trying to find B. So we're trying to find B first, the side. And so we know the angle opposites. We know three angles, two angles and a side. We know this one, right? We know two angles and a side. Nope. Do we know a side? We know a side. Yay.
Do you want to know the big angle?
Sure.
114.15.
Okay, so we know all of our angles now. So we could use, if we have a choice, which one do you think you want to do? Law of sines or law of cosines? Law of sines, totally. So can we make a ratio between what we're looking for, B, and an angle, and some other angle and a side? Okay, when we're looking for B, so we should put B on top. So since we made that distinction up here that we could flip it over, we actually want to put B on top instead of having it inverted on the bottom. That makes the most sense. So I'm just trying to think through my problem. I don't know B. I do know the angle for B. It's 50.19, so I'm going to say sine of 50.19 degrees. So I'm going to put my calculator in degrees. Equals, I need some ratio that goes with it. So what do I need? C, which is how far? 5280 over the angle Ben told me is sine of 114.15. And now you just do math. So we could do cross multiplication and then solve for B. So we've got B times sine of 114.15 equals 5280 sine 50.19. And so I could actually solve for B now. I could put this all in the calculator in one fell swoop because I'm going to divide by sine of 114.15.
Almost got it. 4,444.
4,444. Does it round?
0.98.
So 4,445 feet. Okay, so at a second, I'm going to assume that at 1 second, one person measured the angle this side, the other person measured the angle this side, the third person did the math before they moved, and that's how far they are from mile marker A. Well, maybe they went on a non-windy day and
But like, how did they get? They took a protractor and they just how did they get?
And they threw out like an anchor that had a long, like a mile of string. I'm just kidding. I don't know.
It had to be more. Well, I guess not. It's not 1 mile. But
you could do that, I guess. I don't know. Anyway, but this is a math problem, and it causes us to think beyond what the math problem is. So that's good stuff. Could we also find the distance to mile marker B from where they are in the balloon at that instance? So we would set that up. Oh, we could find the height. Could we find the height? How could we find the height? Like this? So we're assuming it's like straight down to where we're looking for, because the height is straight down. You don't randomly measure height sideways. So now we have a right triangle. You could divide 5,280 by 2 and then do that. Nope. We don't know. We don't know where he is. We don't know whether he's closer to A or closer to B. I don't know that information. So it's not necessarily divided by 2. So we could subtract 90 from this angle value. But look, we have a new relationship between angles. Now this side goes with this angle, not 50.19. Like if we're considering a different side, this side, we still have relationships we can do, right? We could still do sine, but with different angles. So now instead of this side being related to 50.19, right? This side would be related to what? This side, if we're looking at this triangle right here, and this side, what angle does that go with? Now it goes with 90, right? I'm in a different triangle. So now I go 4, 4, 4, 5 goes with sine of 90 equal to, what am I looking for? So we'll call it height because now I have too many letters, over so this is the side, and the relationship, the ratio is between sine of the angle that goes with it. Sine of 15.66 in degrees. So Ben is our calculator. He's going to say 4445 times sine of 15.66 divided by sine of 90. Do you know what sine of 90 is? That's so sad.
Hi, can I run to the bathroom?
Yep.
Is it sine of 90?
Pi over 2.
Okay, that's the place that it happens. Sine of pi over 2 or sine of 90 is the same answer.
Zero.
Nope, that would mean that they're not high at all.
Yeah, because when I just divided it, it did nothing.
Yeah, sine of 90 is 1. Hello, unit circle.
Hello.
It's 1.
It's 1.
Oh, wait, because it's up there.
Oh, yeah.
It's 1,199.8.
Okay, I got the 1. That's all I got. 1.
Well, it's 1,199.8. So you could just round it. Or not.
1,200 feet high. Height. Okay, that's what I was going for. Rounded. So sine, that's pretty easy, right? That ratio. In this particular problem, our triangle changed a little bit, so the highlighting hopefully narrowed your focus from this going with C now. That's how I was able to get height. I didn't have the third side. I couldn't use Pythagorean theorem because we didn't know for sure. We can't assume it's halfway. All they could say was they could see the two angles. And obviously it's not halfway. How do I know that? These angles are different, right? Yeah, so my triangle is not drawn to scale. If it was going to be right smack in the middle, then the angles would have been the same. It would have been an equilateral triangle. That makes sense now? All right. So law of sine and cosine lets us figure out stuff that if you're a master balloonist, that you can do some really high level math as well. Okay, let's use the law of cosine. Okay, so this example is using the law of cosines. And I need the law of cosines because I only have 3, 5, and 7. I have 3 sides. So I go over here, and 3 sides means I have to use law of cosines. So we're going to pick a side to find one of the angles. Then we're going to have to pick another side and find its angle, and then we can find the third angle. Does that make sense to you? Okay, so pick a side. Okay, I heard 3 is a side. So 3, that means I'm looking at, this should be a big A. Sorry, angles are big. So this is little a. So when I do my law of cosines, this is what it looks like again. It's a squared equals the other 2, b squared plus c squared, minus 2, the other 2, b and c, times cosine of the angle that I'm looking for. So y'all check my math and make sure that's right. -2, yep, okay. So it's not hard to memorize. It's whatever you put here and everything else except for the angle. So b and c are squared, minus 2 times the 2 of those, still b and c, cosine of the angle. And then we're going to plug everything else in. So what's a? 3, so that's 9. I can do all this math. So b squared is going to be 25, c squared 49, minus 2 I'll write this one out. 2 times 5 times 7, just not to be confused, cosine of A.
Wasn't it cosine of A?
Nope. I don't know what A is. This is the question, right? I'm looking for the angles. So I don't know that yet. But yeah, we need to know what we're talking about. So what can we do now? So on the calculator, we could go 9 minus 25 minus 49 divided by negative 14 times 5, whatever that is.
What is it?
So it's going to be 9 minus 25 minus 49 divided by negative 15 times 7. 95? No. 3 and 7. 105? Oh, 10. Oh, that's easier. 70. Yay, 70. Sorry, I still had that 3 in my mind. 10 times 7, I can do that. Okay, I did it. Thank you for that.
Wait, isn't it just 7? Never mind.
It is 70.
Okay, I lost you. Let's start over.
We did not go.
9 equals, what's 25 plus 49? 74 minus 70 cosine of A. Subtract the 74. I had that. What is that?
9 minus 74.
Uh-huh. Negative 65 equals negative 70 cosine of A. This is where I have the negative 70 on the bottom. How come? Right now it's multiplied. I need to divide by it. And that's okay because now I've got a positive angle. That makes sense, right? Because positive angles would be important for this triangle to exist. So I've got some decimal. 13 over what?
14.
13 over 14 equals cosine of A. How do you find A? You have to take the cosine inverse of both sides. So undoing cosine of A. To get A free, you have to do cosine inverse of both sides. Cosine inverse only works if this number is less than 1. Because cosine only exists between negative 1 and 1. And this is smaller than 1. Yay. So I did cosine inverse of both sides, so that would cancel. And then you put that in the calculator, and you get 21.8 degrees, because I'm in degrees. We're back to degrees, because that's easier for this particular lesson. And if we know what A is, we still don't know what B and C are until we do this again with B or C. So why don't y'all try that? At least do the setup. If you don't have your calculator handy, we can do the inverse cosine for you. Do the setup for B or C given this equation, or check your other side of your paper, or however your notes are. See if you can find the other angle. And once you know 2 of them, you can find the third one, right? So you just have to do this one more time, and then you can find the third angle. Okay, so I'm going to find B here because we're almost out of time for class. So just because, I don't know if y'all have seen Mr. Shiloh with this. So this is write the formula written in such a way as to not forget that that's helpful to plug stuff in. So write the formula. B, we already labeled this triangle, so that's 25. A is 9 when you square it, 49, and then plug stuff in. I skipped to this step because hopefully you followed what I did last time. 25 minus these guys divided by this, which I multiplied correctly this time. Good job myself. And then we say, whatever that is, it was 0.78571 equals cosine of B. This is a number smaller than 1. Inverse cosine will work on it. And so therefore, if I take cosine inverse in degrees on my calculator, that will tell me B. And I got 38.2 degrees. And then if I know A and B, then 21.8 plus 38.2 is 160. Therefore, the last angle must be 120. Okay. So 3 dots means therefore when you're writing it out. So I could go up here and say A is 21.8 and put it in my triangle so I know what I'm doing. B is 38.2 and C is 120. So you've got problems like this. I have already worked through these. So if you're having trouble drawing a picture, send me what you've drawn and I'll edit it and send it back to you, okay? So the problems that you have are, it's page 620. And the problems are number 1, 2, 3, 6, and 7. So 5 problems. They're due tomorrow by 3. Don't send me something you need edited at 2 o'clock. Try to work them today and send me questions. I'll reply to you, and then you can finish them tomorrow. There's not that many problems. But I would try to draw the picture. You have to. 2:30, I'm going to laugh at you. Just kidding. Okay, so there you go. Law of sine and cosine.